Hello everyone, here is a brilliant question. Suppose there is a parallel plate capacitor and a thin metallic sheet is inserted in between the plates as shown. What will happen to the capacity of this capacitor? I request you to pause the video here and please post your opinion in the comment box, and then we'll be discussing the solution. I hope you got the correct answer, which is the capacity of this capacitor will remain unchanged. The logic is pretty simple. Suppose if the capacitor is charged and here is the electric field lines as shown in between the capacitor plates, and we insert a thin metallic sheet at the equipotential surface, then inside the thin metallic sheet the electric field is always zero, so it won't hamper the electric field in between the capacitor plates. So the capacity of the capacitor will remain unchanged. Got it? Now you can mark this as a brilliant concept. Whenever at the equipotential surface between the capacitor plates, if we put a thin metallic sheet, the capacity of the capacitor will remain unchanged. Got it? Okay. If you have noted down this concept very well, I am bringing up the next question for you. Look at this spherical metallic shell. What is the capacity of this capacitor? It's a simple spherical capacitor. Okay, C is equal to 4 pi epsilon naught R. This spherical capacitor has the other plate at the infinity. I hope you remember this concept. Now, I am enclosing this capacitor in another metallic shell. What will happen to the net capacity of the system? Think about it, and then again I request please post your opinion in the comment box. I hope you got the correct answer, which is the capacity of the system will remain unchanged. How? Let's see it here. Suppose this is a spherical capacitor, radius is R, and we can write C is equal to 4 pi epsilon naught R. The other plate of this spherical capacitor is at infinity. Now we enclose this capacitor in a thin metallic shell. Okay, let's say thin metallic shell has the radius 2R. The electric field lines will be like this. If this capacitor is charged, the pattern of the electric field lines will be like this, radially outwards. Now, this is basically an equipotential surface, and if a thin metallic shell is placed at the equipotential surface, it won't hamper the original electric field of this capacitor. So, capacity of the system will yet remain 4 pi epsilon naught R. Basically, you can solve it. You consider two capacitors in series, one capacitor here, you call it C1, and other capacitor here and in between infinity. Got it? This capacitor C1 and that capacitor C2, they are in series. If you solve their series combination, again your net answer will be C is equal to 4 pi epsilon naught R. Got it? It's a brilliant question. Even if I bring another metallic shell like this, let's say it has the radius 3R, and then again I ask you what is the net capacity of the system between this surface and the infinity. The answer will be again 4 pi epsilon naught R. Now what you will be doing? You will be taking up three capacitors, C1 in between these parts of the spheres, C2 here, and C3 between this surface and the infinity. Solve their series combination. Again, you will be getting the same answer. So, I am repeating the brilliant concept again. If at the equipotential surfaces between the capacitor plates, we insert a thin metallic plate or sheet, the capacity of the system remains unchanged. Hope you liked the concept. Stay awesome. See you again.